Hello. So we have a lot to talk about because we've skipped around a little bit, and there are some pieces of chapter 3 that we need to go back and make sure you understand. The first is this idea of continuity and differentiability. If a function is continuous, let me start that over. If a function is differentiable, then it is continuous. All differentiable functions are continuous. However, continuity does not imply differentiability. So for instance, if you look at the picture on the screen, this function is continuous, you never have to lift up your pencil, but it is not differentiable because of that point right there. So AP loves to ask questions about piecewise functions and where they are continuous and differentiable. So we're going to look at this. As I was saying, the AP loves to ask questions like the following. Find A and B to make this function continuous and differentiable. So the first thing we have to do is figure out how to make it continuous. Once we make it continuous, then we can try to make it differentiable. So we know that in order for it to be continuous, the limit from the left and the limit from the right have to be the same, and they have to equal f of 1. So basically we're going to find f of 1 from the left, and hopefully you can see that that would be 3. F of 1 is 3, and the limit as x approaches 1 from the left is 3. On the right, when we put in 1 for x, we get 1 minus 1 over 1, which is 0, times a, which is 0, plus b. But we know that to be continuous, we need this value to equal 3, because it has to equal the limit from the left, and it has to equal f of 1. So we need b to be 3. I hope that makes sense. So now that we know that b is 3, now we need the derivative on the left and the derivative on the right to be equal. Well, the derivative on the left, y prime from the left, is 2x, and at x equals 1, this value is 2. The derivative from the right is, how do we want to do this? There's a lot of ways you could go about it. I'm going to do the product rule. So I'm going to say a times the derivative of the inside. Well, this derivative is 0. I'm going to write that just for good times. And this is the same as x minus 1. So the derivative of that would be plus x to the negative 2. And then, so that's first times derivative of the second plus second times derivative of the first, but a is a constant, so I don't have to do that. And the derivative of 3 is also 0. So this is my derivative, better written as a over x squared, right? And that's when x is 1. So if I plug in 1 here, then I just get a. And that's the derivative on the right, is a at x equals 1. But I need it to be 2, because I need it to equal the derivative on the left. Therefore, a must be 2. So once again, first you have to find what makes them continuous. Basically, you just plug in 1 on the left, plug in 1 on the right, write an equation to set them equal, and find out what the answer is. And then to make it differentiable, you have to find the derivative on the left, plug in the x, find the derivative on the right, plug in the x, and make those two things equal. Okay, the next thing I want to talk about is this type of question involving an area. Number 2 says write the area of a circle as a function of the circumference c. So the first thing we have to do is, I don't want to use the answer book because I don't want you to see that. Just don't look at the blue stuff. The area as a function of the circumference. Well, hopefully you know area equals pi r squared. And hopefully you also know that circumference equals 2 pi r. But I need circumference to be in this formula because it wants area as a function of the circumference. So I need to solve this equation for r and then stick it in there so that there's a c. So r equals c over 2 pi. And then I'm going to have to square that in order to put it in here. Well, actually, I'll write it like this. A equals pi times c over 2 pi squared. Let's keep simplifying. A equals pi times c squared over 4 pi squared. Let's keep simplifying. A equals c squared over 4 pi. That's the area in terms of the circumference. Now the next question says, find the instantaneous rate of change of the area with respect to the circumference. And hopefully you remember instantaneous rate of change is the derivative. So I want A prime, and I have to do the, well, I kind of have to do the quotient rule, but if you think about it, this is a constant. So I'm really saying 1 over 4 pi times c squared. And we know that when there's a constant, the derivative is the constant times the derivative of the function. But I'm just going to do product or quotient rule to review it with you. So low d high minus high d low, which is 0, because derivative of the bottom is 0, all over low low. So one of these crosses off with one of these, and I end up with 2c over 4 pi, which reduces to c over 2 pi. And we can talk about units in a minute. The next question says, evaluate the rate of change of A at c equals pi and c equals 6 pi. That's instantaneous rate of change. How do I know it's instantaneous rate of change? Because it didn't say between, where am I? It didn't say between pi and 6 pi. It said at pi and 6 pi. So those are two different instances. So the instantaneous rate of change at pi equals pi over 2 pi, which is 1/2. And the instantaneous rate of change at 6 pi is 6 pi over 2 pi, which is 3. If c is measured in inches and a is measured in square inches, what units would be appropriate for dA dc? Okay, so this says a equals c squared over 4 pi. And a is measured in square inches, and c is measured in inches, so that's also inches squared over 4 pi. When you take the derivative with respect to c, you're saying the change in a over the change in c. So you're really saying over inches. And then let's think about this for a minute. That's it. So dA dc is inches squared per inch. Final answer. Okay, so that's that one. There's one more thing I want to talk about that's on your homework, and that's particle motion. So let's find a particle motion question here. T squared minus 3t plus 2. I don't think I gave you that one, so let's talk about this one. A particle moves along a line, so its position is given by the position function. And hopefully what you've gotten, I'm going to cover up these answers so you don't look. What you've gotten out of all of our discussions of graphs is that velocity is the derivative of position, acceleration is the derivative of velocity. So write that down if you haven't already. S of t V of t equals S prime of t, A of t equals V prime of t equals S double prime of t. Velocity is the derivative of position, acceleration is the derivative of velocity, also known as the second derivative of position. So this question, find the displacement. Well, we're talking about the position function. So meaning, where did it start? What was S of 0? And where did it end up at 5 seconds? So we need to find these two values just by plugging in to the position function. So when I plug in 0 for t, I get 0 minus 0 plus 2. S of 0 is 2. S of 5 is 25 minus 15 is 10, plus 2 is 12. So what's the displacement? How far did it move in the first 5 seconds? 10 units. And I think we're talking about meters, 10 meters. Find the average velocity. Well, we've learned so far that average means slope, and velocity is the derivative of the position function. So the velocity is 2t minus 3, and the average velocity for the first 5 seconds means v of 5 minus v of 0 all over 5. So plug in 5, you get 7. Plug in 0, you get minus negative 3, which is plus 3, all over 5. And the question is 2 meters per second. Find the instantaneous velocity when t equals 4. Instantaneous velocity. That's the derivative of the position, which is this, at the time t equals 4. So you just plug in 4 and you get 5 meters per second. Find the acceleration of the particle when t equals 4. Well, acceleration is derivative of velocity, so the answer is just 2. All the time. It's constantly accelerating at 2. At what values of t does the particle change direction? Now, think about the position function. What does it look like? Well, it looks like a parabola with roots at 2 and 1, because this would factor into minus 2, minus 1. So at positive 1 and positive 2, it crosses the x-axis. Oops, make that a 2 right there. And we said that when the position was decreasing, the velocity was negative. When the position starts increasing, the velocity becomes positive. So what does that mean for changing direction? Well, that means that it's moving, well, first we have to think about the position. When it's decreasing, it's moving to the left. When it's increasing, it's moving to the right. When it passes through the origin, that just tells you where its position is. But this is the point where it changes direction. And this is the point where the velocity equals 0. So we would take our velocity function, set it equal to 0, and solve. So at t equals 3/2, the particle changes direction. Where is the particle when s is a minimum? So when t is 3/2, where is s? So you have to plug in 3/2 for your time. So you get 9/4 minus 9/2 plus 2. I don't have a calculator right now. 9 minus 18 is negative 9 plus 8. It looks like it would be at negative 1/2. Or negative 1/4. Oh yeah, that makes sense. Negative 1/4. Okay, I hope that makes sense. And you can also tell that since the function is concave up everywhere, the acceleration should be positive for the whole function. And we found that to be true. We found that it was positive and that it was constant, because this function never turns and goes concave down. So that's just a little talk about the acceleration. Now there is a question on your homework about speed. All you have to know about speed is it's the absolute value of the velocity. Speed is the absolute value of velocity. Let's see if there is a question about speed that I didn't give you. Well, that's the one I did give you. Basically, when you do the problem, find the absolute value of velocity to find the speed. Alrighty, that should be all you need.